Le Chatelier and pressure. Okay, so now we're talking about pressure and Le Chatelier's principle. And the thing about this is that the concept of Le Chatelier's principle is, of course, recognized for Henri Le Chatelier. And he basically said that when an equilibrium system is perturbed or changed by some particular factor, then that equilibrium system will move in a direction to minimize the change. And sometimes Le Chatelier's principle is sometimes referred to as the LCP, Le Chatelier principle, right? So let's check out what happens if we change pressure. Here we have our good old system that we saw before in a previous video, and we've got some dinitrogen tetroxide, which is colorless, and our colored nitrogen dioxide. Now the thing here is that pressure or volume changes all the substances in the reaction, or all gases, right? So if they're all gases, their concentrations are going to be affected by a change in pressure and a change in volume, because those two are pretty synonymous. You know, if you change one, like you change the pressure, how do you change the pressure? Well, you can change the pressure by changing the volume size. That's going to change the pressure. So some questions will say a pressure change occurred where the volume was increased or decreased. And so just keep in mind that pressure and volume are pretty much the same thing in terms of the effect on the equilibrium reaction. So let's have a look at this graph here, okay? They're all hunky-dory, they're all nice and equilibrium up until around about 2 minutes time. Just before the 2-minute mark, something happened. So you can see there's a sharp spike going with the nitrogen dioxide, but there's also a sharp spike with the dinitrogen tetroxide. So both chemical species were affected. And so therefore what should be clicking off in your brain is pressure. The pressure, something's happened to the pressure or the volume. So if they're both going up, it means that the volume has been decreased and therefore the pressure is increased, right? And so we can see that both their concentrations have increased. Now, Le Chatelier's principle states that it moves in a direction that minimizes the imposed change. Now, with gas molecules and equilibrium reactions, if you're decreasing the volume, that is by increasing the pressure, let's say, for example, if you're doing that, then the molecules have less space to move around. And so the system wants to go into the direction that minimizes that change. In other words, it goes to the side with the least number of gas molecules. That means there will be lower collisions between the gas molecules. So if we look at our equation there, we can see that we got 1 mole of gas for nitrogen tetroxide and 2 moles of nitrogen dioxide. So if we increase the volume, if we increase the pressure, then it's going to go towards the left. It's favored towards the left because the left-hand side has the least number of moles of gas molecules, therefore less collisions are occurring, and the equilibrium system, the equilibrium position re-establishes itself. So let's check out the graph. Does it show that? Excuse me, it's late. So let's see, does it show that? Well, if we have this change, the pressure is increased, and then we can see that the concentration of nitrogen dioxide goes down, which is consistent with going towards the left, and the concentration of dinitrogen tetroxide goes up a little bit. So it is showing us from the graph that it's favoring a shift from the right to the left because of the least number of moles of gas. That's it. All right. So that same basic concept happens whether you're decreasing the volume or increasing the volume. If you're decreasing the volume and making it larger, then the opposing change would be to go to the side with the most number of gas molecules. Anyway, that's Le Chatelier in pressure and volume, and I hope it makes sense, and I'll see you in the next video.